link, so anybody who's missed this can just catch up. I hope you can see my screen and let me know in the chat if there are any problems. Otherwise, we can just get started. So we're basically done with complex numbers. I hope you tried those questions that we didn't do in class. They shouldn't be too difficult. It's just applying the formula. And remember, the principal value or the principal argument is always the smaller angle. You measure it clockwise and anti-clockwise, and the one that gives you the smaller one is your principal argument. Now, in the case where it's 180 and minus 180, you must choose the positive one, okay? So otherwise, you pick the smaller value. Then today we start on the next chapter. I sent you the scanned copy of the chapter, so if you don't have it, you can just download it over there and then you can follow with me. So this is coordinate geometry. Oh, goodness. Okay, so we start with the very basic things, which I'm sure even from high school you remember. I'm hearing a lot of noise in the background. Please mute your mics. Okay, and if you have a question or a comment, then you can unmute yourself. So please mute your mics. Okay. Hearing noise, please mute your mics. Okay, so the first thing we look at is the distance between points. So we have the distance. So if you have your Cartesian plane, this is the Cartesian plane, the x and y axis. This is your x, and that is your y-axis. And then I give you 2 points on the plane. It doesn't matter where they are, so I'll just put them one there and another one over there. The first point A, I'll call it x1, comma y1, and the second one B, I call it x2, comma y2. Now, if I want to work out the distance between these 2 points, I would have to draw a line connecting them. Then what I'm going to do is use Pythagoras' theorem to help me work out what the distance is. So to do this, I have to form a right-angled triangle because Pythagoras' theorem only applies to right-angled triangles. So that's what I have. Now with Pythagoras' theorem, if I know the sides, the lengths of the 2 shorter sides, then I can always work out the hypotenuse. The hypotenuse is this line here, AB. So this is some point C. Now if I were to do this, the x-coordinate of A is x1, and the y-coordinate is y1. The x-coordinate of B is x2, and then the y-coordinate of B is y2. So this length AC, if I wanted to work it out, I would just say x2 minus x1. Okay, so you can try it on your ruler. You have any 2 numbers and you want to find out what is the distance between them. You just say the bigger one minus the smaller one. That will give you the distance between those 2 numbers. And then in the same way, the distance over here, that is y2 minus y1. So if you look at it, I have a right-angled triangle that looks like this. This side here is x2 minus x1. This one is y2 minus y1. This is right-angled. So if I want to work out the length AB by Pythagoras theorem, AB is just equal to the square root of this distance, x2 minus x1 squared plus y2 minus y1 squared. And I'm sure you've seen this formula before, but now you know that is where it comes from. So we use Pythagoras theorem in order to derive this formula. It doesn't actually matter which one is x1 or x2 because you are squaring it. So if you say the smaller one minus the bigger one and then you square it, let's say I get minus 2. When I square it, it's 4. And if I'd done it the other way, I would say 4 minus 2 is 2. I square that, it's still equal to 4. Okay, so let's look at an example. Just go over the one in your book. This is minus 1, 3. B is 1, 1. And then C is 6, 3. Now we are asked to calculate the perimeter of this triangle. So any 3 points you have will always make a triangle and connect them. It makes a triangle. Then we're asked to find the perimeter, so that means I need to work out the distance AB. AB is just the square root of minus 1 minus 1. So I take the x coordinate minus the other x coordinate, and then I square. And then I take the y coordinate 3 minus the y coordinate 1, and then I square. So this is 3 minus 1 squared. Okay, minus 1 minus 1, this is 2. 2, it's negative 2. Negative 2 squared, this is equal to 4. So I have 4. And then 3 minus 1, that is 2. And then 2 squared, that is also equal to 4. So I have 4. Okay, then this is equal to the square root of 8. So we can leave it like that. Then we want BC. This is the square root of 6 minus 1 squared plus 6 minus 1 squared. Now this one you can just do it on your calculator in one step. Let me see. Square root. This is equal to 5 square root of 2. Okay. So 6 minus 1 is 5. 5 squared is 25. The same thing over here. This is 25. 25 plus 25 is 50. The square root of 50 is the same as the square root of 25 times 2. Square root of 25 is 5. Okay. Try and scroll up. Okay. And then we need AC. AC, this is the square root of 6 minus negative 1 squared plus 6 minus 3 squared. Okay, so 6 minus negative 1 is 7, and then 7 squared is 49. 6 minus 3 is 1.5. Okay, and then 6 minus 3 is 3. 3 squared is 9. The square root of 49 plus 9, this is just equal to the square root of 58. Okay, so to find the perimeter, all I do is I combine all the lengths that I have over there, the square root of 8, 5 root 2, and then root of 58. So my perimeter this is square root of 8 plus 5 square root of 2 plus the square root of 58. Okay, so square root of 8 square root of Okay, I am getting the square root of 58 plus 7 square root of 2. And you can leave this to 3 decimal places. This is 17.515, and then you put units. Okay, so you must always put units. Then the second part says we have to prove that this is a right-angled triangle. Now, if this is a right-angled triangle, then Pythagoras' theorem is true for this triangle. So that means if I square two of the shorter sides, then it should be equal to the square of the other side. Okay, so I have side 1, square root of 8. Okay, so when I square this one here, I get 8. Side 2, I have 5 square root of 2. When I square this, this is 50. And square root of 58, when I square this, I get 58. And then here you can see that if I was to add these two sides over there, I would get the square of the other side. So now that I've squared them, I can write, I think number 1 was AB squared plus, actually don't need brackets like that, AB squared plus BC squared. This is equal to AC squared. Okay, so because it follows Pythagoras' theorem, it means that this is indeed a right-angled triangle. So I would substitute the values that I got here, write them there, and this one, write it there, and then I will conclude, and then therefore ABC is a right-angled triangle. Okay. Then we look at some of the exercises in 9.1. Exercise 9.1. We're given points. We just have to determine the distance between them. That isn't difficult. It says leave the distances in simplified root form. So instead of to 3 decimal places. So the first one, I have A is 1, 2. The second one, B, is 3, 5. So the distance AB, I'm just using the formula. This is the square root of 1 minus 3 squared plus 2 minus 5 squared. 1 minus 2, sorry, 1 minus 3 is minus 2. Minus 2 squared, this is just 4. And then 2 minus 5, that is minus 3. Minus 3 squared, this is 9. So this is the square root of 13. And then I put my units. So distance should always have units. Number 2, C is 0, 1, and D is -2, 4. The distance CD, this is just the square root of 0 minus -2, and then I have to square it, and then 1 minus 4 squared. Okay, 0 minus -2 is just +2. Positive 2 squared is 4. And then 1 minus 4, this is equal to 3. I don't know why my screen keeps going black. Let me see if I can fix that. I hope this will be better. Okay, and then 1 minus 4 is -3. -3 squared is equal to 9. So I have 4 plus 9. This is also the square root of 13. And leave it like that. Okay, then number 3, 4, and 5. Those you can do. You can go and try them. Then let's look at number 6. Number 6, we have M is -A, -B, and N is A, B. So it doesn't matter in what form the points are given in. All you have to do is apply the formula. So the distance MN, this is just equal to the square root of A minus -A. I'm going to square this. And then I say B minus -B, and again I square this. Okay, A minus -A, that is equal to 2A. So I'll just write that. This is the square root of 2A. Then I square this. And then B minus -B, this is 2B. Then I will have to square this. Then 2A squared, that is 4A squared. So I have 4A squared. Excuse me. And then I have 4B squared. Now I can see that 4 is a common factor, so I can factorize it. This is equal to the square root 4A squared plus B squared. And then when we have a product and we're taking the square root of a product, you can always split it like this is the square root of 4 times the square root of A squared plus B squared. Okay, square root of 4, this is just 2, and then I have A squared plus B squared. So it's not plus or minus 2, it's just 4 because this is a length. Okay, so it's 2 square root of A squared plus B squared. Now A squared plus B squared, you cannot separate them or simplify it any further. So that is how you will leave that one. Then we have the center of a line segment. Okay, so with this one, again, you have your X and Y plane. You have a point here A, which is X1, Y1. And then you have another point somewhere there, B, which is X2, Y2. Now you have a line segment that connects them. And if you want to work out what is the point that is exactly halfway of the line segment AB, so you want to work out its coordinates. Here you're working out the points, not the distance. Okay, so the coordinate, the x coordinate over here, this is x1. The x coordinate over here, this is x2. Okay, and the y coordinate here is y1. Then the y coordinate over there is y2. So to work out this point that is exactly halfway between x1 and x2, what you do is you just add the 2 points and then divide by 2. Okay, so just like when we have your ruler, you want to find out what number is halfway between 4 and 5. You will say 5 plus 4, and then you divide by 2. You'll see that your answer is 4.5. You want to find out what number is halfway between 3 and 5. You say 3 plus 5 is 8, and then 8 divided by 2 is 4. So the same thing over here. This point is just x2 plus x1, and then I divide by 2. So that is the x coordinate. And then the y coordinate, I do the same thing. It is y2 plus y1, and then divided by 2. So you can have x1 plus x2 divided by 2. It's the same because addition is commutative. The order that you add them in doesn't actually matter. So we sometimes call this capital M. We denote it with capital M. So the midpoint, capital M, of A, B, the line segment connecting A and B, has coordinates x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Those are the coordinates. Okay, then we can look at an example where we have to find the coordinates of the midpoint. So we are given point A is 1, 1, B is -5 and 7. Now I want to find the midpoint of A and B. This is just the average of the x coordinates and the average of the y coordinates. Now to do that, I will say 1 plus -5 . Then I divide this by 2, and then 1 plus 7, I divide this by 2. Okay, 1 plus -5 divided by 2, that gives me -2. Okay, because 1 plus -5 is the same as 1 minus 5, 1 minus 5, which is 4. -4 divided by 2 is -2. And then 1 plus 7 is 8. 8 divided by 2 is 4. So notice here, the midpoint is a point. That's why it's called a midpoint. So it's not distance. I don't put units. I leave it like that. All our coordinates must be in brackets like this. So I have brackets, I have an x coordinate, I have a y coordinate. So I do not write something like this, -2 fourths. So please, this is wrong. It must have brackets, then it is correct, and it is coordinates. Another example, we have points 3, -2, and B is -3, 4, and then we are told to find the midpoint. so the midpoint of AB, again, this is just the average of the two. So this is 3 plus negative 3. I divide by 2. And then minus 2 plus 4. And then I divide this by 2. Okay, this is just equal to 0, comma 1. Because 3 plus negative 3 is 0. Divide that by 2, you get 0. Negative 2 plus 4 is 2. 2 divided by 2 is equal to 1. Now, what if my coordinates are just AB and BA? Okay, so it doesn't matter in what form your coordinates are given in. What you do is follow the formula in the same way. So if I call this one point A and this one B, the midpoint capital M of AB, this is just A plus B divided by 2. And then here I will have B plus A, but I think A plus B looks better, divided by 2. So that is what I would have. Okay, so you can write B plus A, but B plus A and A plus B is the same thing. So it doesn't actually matter. Okay, then there are cases where you are actually given the midpoint, and you're told that the midpoint is minus 3, 2, and it is the midpoint of the point A, which is minus 3, minus 7, and another point B. And then you're asked to find what that point is. So you know the midpoint. You have a line segment like that. You have minus 3, minus 7 over there. This is your A. And then you know the midpoint M over here. This is minus 3, 2. Now you're asked to find out what B is equal to. Okay, now this, again, you just use the midpoint formula. So B, since you don't know what its coordinates are, you will just call it X, comma Y. Okay, then you use the formula as usual. So the midpoint of AB, this is equal to X minus negative 3 divided by 2, and then Y minus negative 7 divided by 2, like that. Okay, and this midpoint, we already know its coordinates should be equal to minus 3, 2. So both of these, that one and that one, those are midpoints. And if they're the same midpoints, then they must be equal. So when I simplify the big brackets, I will have X plus 3 over 2 and Y plus 7 over 2, and this is equal to minus 3, 2. Okay. Okay, now I have 2 points that I say are equal. Now 2 points are equal if and only if their x coordinates are equal and the y coordinates are equal. So this means that x plus 3 over 2 is equal to minus 3, and not or, and y plus 7 over 2, this is equal to 2. So both of those must be equal, then those points are equal. So with the first one, if x plus 3 over 2 is equal to minus 3, this means x plus 3 over 2 is equal to negative 6. Okay, this means it is equal to negative 6, and that means x is equal to negative 9, if I've done that correctly. Okay. And then for the y coordinate, I have y plus 7 over 2, so y plus 7 over 2, and this is equal to, okay, this is equal to 2, so I put a 2 over there. So this means that y plus 7 is equal to 4, and this means that y is equal to 4 minus 7, which is negative 3. So your point B is negative 9, comma, negative 3, like that. Okay. Okay. Then another example, we are told that,
Miss,
yes,
for that example, could we just confirm the coordinates by using A and B and seeing if it gives us M?
yes, you can.
Ma'am,
Mm-hmm.
why did we minus? The formula says plus, but here we said x minus negative 3 and then y minus negative 1. Should it not be plus? Or when you're
Yes.
finding another point, is it minus?
Sorry, I'm thinking of distance, I think. What did I do? Yes, that's why I did it like that. Sorry, guys. This is plus. This is plus. Okay, let me just correct all these. So this is minus, 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 minus. Goodness, I can't scroll up. Okay, so let's just. Okay, so I should have x minus 3 over 2 is equal to minus 3. I think that is correct now. Okay, and then I will multiply by 2. So I have x minus 3. This is minus 6. This means that x is equal to negative 3. And then I also have okay, then for the other one, I have y minus 7 over 2, and this is equal to 2. So I multiplied by 2 on both sides. So y minus 7, this is equal to 4, and that means that y is equal to 11. So I have 4 plus 7, that is 11. So my coordinates of B should be minus 3, 11. Yeah, that is correct. Okay, I'm not scrolling up now. Okay, then with the next question, we are given a diameter of a circle. We're told that these points A, minus 1, 9, it's a 9, and B, is -2, -1. These are the endpoints of the diameter of a circle. So you have some circle that you can draw, and then you have your point A there and your point B over there. Now you are asked to work out what the center of the circle, what the coordinates of the center of the circle are. Now here you should realize that the center is the midpoint of the diameter. So we just use the diameter. So here I'll just put A and B and then C. So here C is the midpoint. So I say -1, -2, or plus -2. Then I divide this by 2, and then 9 plus -1, and then I divide this by 2. Now this is equal to -3/2 for the first one. And then for the second one, 9 minus 1 is 8. 8 divided by 2 is just equal to 4. Okay, I can't scroll back now. All right. Okay, so the last question, you can go and try that one and see if you're able to get it, but it's pretty simple. With the points A and B, you're told that M is the center. So first thing you need to do is work out the center, and then there is something that you need to show. You need to show that the distance from the origin to M is equal to the distance of A to M, which is M to B. So A to M and M to B is already equal because M is the midpoint. The only thing you need to show is that OM is equal to all of those. So you can go and try that one. The next thing I want to talk about is the inclination of a line. Now, if you have a new line on your x and y-axis, so this is your x-axis, that is your y-axis. Now, let's say I draw a line like this. This is my line. Now, the definition of the inclination is just the angle that the line makes with the positive x-axis. Now you measure this angle anti-clockwise. So you measure it like that. And the angle that you have here, that theta, is called your inclination. Okay, so when we ask you what is the inclination of a line, this theta is what we're talking about. What is the angle between that line and the positive x-axis? Now the line can also face in the other way. So let's say my line looks like that. So this is my x and y axis. So I must measure the angle like that. So over here, this theta, this will now be the inclination. So the inclination is just the angle that the line makes with the positive x-axis. It is always measured anti-clockwise, so it is always a positive value. Now the gradient of a line, that was just a definition, because we're going to use this, or we're going to use it. The gradient of a line is actually equal to tan of this angle theta. So we say m, small m, that is how we denote the gradient. This is actually equal to tan of theta. So if you know the angle of inclination like we do over there, you take tan of theta, and then that is your gradient. Now you'll notice over here, theta is it is an acute angle. And when I take tan of this acute angle over here, my gradient will be positive. And I'm sure you know already that a line like this has a positive gradient. It is increasing. And then this one over here, this angle is greater than 90. Now when I take tan of this angle over here, it is going to be negative. And I'm sure you know that a line like this has a negative gradient. Okay, now just to talk about where this tan theta comes from. How did we come up with this formula? You can derive it. It's not too difficult. Okay, so again, we have our x and y axis, and then I have a line like that. Okay, so I have 2 points on the line. So this point here has x coordinate x1, the y coordinate is y1, and there's another point over there. The x coordinate is x2, and the y coordinate is y2. Now the angle theta is over here. Now what you can do is you can move the x-axis. This is my x-axis. You can move it upwards until it reaches this point over there. So this red line is me moving the x-axis up so that it touches this point. Now this angle here is theta. It means that the angle over here must also be equal to theta, because it's still the angle between the x-axis and the line L. Call it L. Okay, so the angle should still be theta. Then I can form a right-angled triangle. It goes like that. If I form this right-angled triangle like that, then this length over here, like we did before, this is just equal to x2 minus x1, and this one over here, this is just y2 minus y1. Now if I wanted to work out this angle theta over here, I use my socket here. I have the adjacent and I have the opposite. So this is the adjacent and this one is the opposite. So obviously I have to use tan. So I will say tan of theta. This is equal to the opposite, which is this one, which is y2 minus y1. And then I divide it by the adjacent. The adjacent is this one that we have over there. Okay, and that is x2 minus x1. So x2 minus x1. And I'm sure you've seen this formula before. So remember I said tan of theta, this is our gradient, m. So m is equal to y2 minus y1 over x2 minus x1. Sometimes we write delta y over delta x. Delta just means the difference. So the difference in the y coordinates divided by the distance in the x coordinates. Okay, so that's where the formula comes from. Now, if our theta, I mentioned this already. Now, if theta is acute, then obviously tan of theta is greater than 0, because if it's acute, it's in the first quadrant. Tan is positive in the first quadrant. So here tan, which is m, is positive. So if you have an acute angle, your line is increasing. It has a positive gradient. Now if theta is obtuse, then we know that m, which is equal to tan of this angle, is less than 0, because obtuse means that it is in the second quadrant, and if it's in the second quadrant, tan of theta is negative in the second quadrant. So your angle, your line will look something like this, and this is a line with a negative gradient. Okay. Okay, now two lines. We can talk about parallel lines. Parallel. Now two lines are parallel if and only if they have the same inclination. So what that means is if I have my x and y axis like that, and I have two lines, this is one line and this is another one. This is L1 and this is L2. Now in order for these two lines to be parallel, the inclination has to be the same. Now if the inclination, remember, is this angle here that it makes with the positive x-axis, this angle over here. So here I have theta 1 and over there I have theta 2. So if they have the same inclination, then it means that they are parallel. So what I have is this, theta 1 is equal to theta 2. Now if I take tan on both sides, I haven't changed anything. So I have tan of theta 1 is equal to tan of theta 2. Okay, but remember tan of theta is the gradient. So I have m1 and this is m2. So two lines are parallel if and only if they have the same gradients. So that is where it comes from. So you've been using it, I'm sure, from high school. You know that two lines are parallel when their gradients are equal. This is where it comes from. Excuse me. Then we can also look at perpendicular lines. I'm sure you know that two lines are perpendicular if and only if the product of their gradients is equal to -1. But now the question is, where does that formula come from? So you can draw a sketch. I hope I'll be able to draw it nicely. Okay, so you have two lines over here. Draw one and another one like that. And let's say the angle between them is 90 degrees. Now this is line 1 and this one is line 2. Okay. Now, line 1 has an inclination of theta 1. Line 2 has an inclination theta 2. So theta 2 is the angle between the x-axis and the line, the positive x-axis. So this angle here is not the angle of inclination of theta 1 of line 2. Okay. Now this is a right angled triangle. Okay, and we also know that all the angles inside the triangle should add up to 90 degrees, should add up to 180 degrees. So this point, this angle over here, if I wanted to work it out, I would just say 180 minus 90 minus theta 1. So I'll say 180 minus 90 minus theta 1. This is just 180 minus 90. This is just 90 minus theta 1 because 180, 180 minus 90 is 90. So that's what I have over there. So if I put it, this is 90 minus okay, so that's what I have over there. And then you should also see that these two angles will add up to 180. The reason they add up to 180 is because this x-axis is a straight line, and angles on a straight line add up. They add up to 180 degrees. Okay, so I have 90 minus theta 1 plus theta, plus theta 2. This is equal to 180 degrees. So I say this x-axis is a straight line. So I have a straight line and I divide it into two angles. These two angles must add up to 180 degrees. So that's where I get this formula from. Then this leaves me with theta 2 minus theta 1. This is equal to, when I take the 90 to the other side, I have 90 degrees. So theta 2 minus theta 1 is equal to 90 degrees. So this result, we are going to use it. What we do is we are going to take cot of theta 2 minus theta 1. So if I take cot of theta 2 minus theta 1, now I hope you remember your identities of tan of a sum of angles. Now cot of sum of angles is just the reverse or the reciprocal of that one. So this is just equal to 1 plus tan of theta 2 tan of theta 1 divided by tan of theta 2 minus tan of theta 1 from your identities. Okay, but then we also know that this theta 1, sorry, theta 2 minus theta 1 is equal to 90. We have it over here. And cot of 90 is equal to 0. So this is equal to 0. Okay, so I say that this theta 2 minus theta 1 is equal to 90, but I can expand it using my identities, and the answer must be equal to 0. So if I have a fraction and the answer is 0, it means the numerator is the one that is equal to 0, because we cannot have a denominator that is equal to 0. So that means I have 1 plus tan theta 2 tan theta 1. This is equal to 0. Okay, then I take the 1 to the other side. I have tan of theta 2 tan of theta 1. This is equal to minus 1. But then remember, when we take tan of the angle of inclination, this gives us our gradient. So this is m2, and tan of the angle of inclination of line 1, this is m1. So I have m1 times m2, this is equal to minus 1. So two lines are perpendicular if the product of their gradients is equal to minus 1. We can also have it m1, this is minus 1 over m2. Okay, so that is what we have. I think we'll stop with this result for today. Do you have any questions? Are we all fine? Okay, if there are no questions and everything is fine, I will post this on the group as soon as I have it on YouTube. Now for tomorrow, I have a meeting. What time is our class supposed to be? Is it 8:30 or 9:30? What time is class supposed to be? I don't have my. Okay. So for tomorrow's class, I don't think we will be able to have it at the usual time. So I don't know if you guys can attend the class in the afternoon. Let's say 2 o'clock. You can unmute your mic so I hear your opinions. Hello.
Excuse me, ma'am.
Can we have the class in the afternoon, say at 2 o'clock tomorrow?
That will be fine, I believe.
Yeah.
Okay, tomorrow 2 o'clock. The rest of you guys?
Yes, it's fine.
Okay. If you cannot attend, then as usual, I'll just record it and then send it to you guys when we are done. Sorry?
Alright.
Okay. Right then, I will see you guys tomorrow.